I mean, can you
Okay.
hear me?
Yeah.
I don't know if this is on.
It's on. What the fuck, I don't need that. Okay, you're on.
Okay.
I'm going to go live now. Hi, guys. Today it is like Tuesday. As I was saying that we have our math class here. Math class, English and Creole. So where me and Mr. Prosper, we are going to talk about two very important basic topic. So therefore, guys, before we go full blown into algebra, pre-algebra, we are going to talk about algebra properties and other operations. And this is our English math class. So Mr. Prosper, as customary, is going to be studying the English part of it, and then me, I'm going to come over, and then I'm going to start the Creole part. As I said earlier, guys, in my previous classes, I said that sometime I will introduce some English word with my Creole. So I'm going to interchange between Creole and English. So guys, it is the first time I'm doing it live on TikTok, but the first two classes was on YouTube. And now I decided to also include TikTok on it. So if you are watching me on TikTok, welcome to our English math class. So my name is Franz Poland. I used to be a teacher for 27 years for the ones that are watching me on TikTok. And actually, Mr. Prosper, it is in his 5th or 4th years of teaching. And it is an excellent math teacher. And I have learned a lot from him. Primarily, when I used to teach 6, 7, 8, and 8th graders math. So I never taught 10, 11, and 12 graders. So it is when I started working with Mr. Prosper that I started learning and taught myself calculus 1, algebra 2. So I have learned a lot because I do tutoring now in the afternoon as a side gig, as a retiree. So I do get into contact with high school kids that are in 11, 12 grades that need help in math, and then also kids that left first and went to college and come back when they are taking calculus. And Mr. Prosper was very instrumental in helping them. By associating myself with Mr. Prosper, I kind of teach myself also some calculus. So guys, without any further ado, je vais enseigner nous la mathématique. Haïtien, yo côté nous y là, nous parlons en pile. So même c'est en créole que je vais teach, Mr. Prosper va teach en anglais. Mais quelquefois je vais parler en anglais tout parce que je fais presque 27 ans à enseigner mathématiques en anglais. So la prochaine est difficile pour moi pour me perdre anglais à net pour créole là. But anyway guys, bear with me. Mr. Prosper, come. Okay. Take over, Mr. Prosper.
Hello, everyone. Thanks for having me. I'm Mr. Prosper. Hopefully, if you remember from the previous videos, we started off with like all the types of numbers out there, the real numbers. I'll just do a brief recap so it can explain like how we go from the real numbers, what they are, to what we're going to talk today first, algebraic properties, and then ultimately order of operations. Again, Mr. Paul and I, we came up with this idea of making pre-algebra, algebra 1 classes available online for specifically Haitian-speaking students, because in my high school, it's very predominantly Haitian students, right, in New York City. And I know a lot of them could do better if there was a way for me to get the math to them language-wise, right? I don't know Creole, Mr. Paulin does. And so, again, our goal for these videos is to sort of hopefully get the math simplified so that anyone can understand it, but also in a way that Mr. Paulin can explain it in Creole. So again, I just wanted to go over briefly what we did before, right? Last video, we talked about natural numbers, right? Natural numbers were 1, 2, 3, 4, 5, 6, onward. And then we went to whole numbers. And all whole numbers did was include 0. Whole numbers just include 0, 0, 1, 2, 3, 4, 5, 6, 7, onward. And then we had integers, right? Because now you have zeros, you can get negative numbers. So integers, -1, -2, -3, -4, to negative infinity, like Mr. Paulin said last time, or 1, 2, 3, 4, 5, 6 to positive infinity. But then, right, you have numbers that are rational, and hopefully I was able to explain it very simply. Rational numbers are numbers that you can show as a ratio, as a fraction. Those would be the numbers in between, right, the whole numbers. But even a whole number can be considered a rational number because you could turn a whole number into a fraction. And then we talked about irrational, which is outside of rational. So if you can't change it to a fraction, like the number pi, that's irrational. And then we said all these numbers were real numbers. Right? All these numbers are real numbers. That was the last video. So then we go now to algebraic properties. Right? And that's just a fancy way of saying, like, now that we know all the real numbers, or classified all the real numbers, and we know what they are, what if we try and do things to them? Right? What could be those things that we could do to those numbers? Right? That's the way to look at it. Well, the first one is commutative property. Commutative property. And like the word says, to communicate is to move. Right? I'm sorry, to commute. To commute is to move. Right? My commute this morning on the bus to school, right? My commute to work on the subway. So all this means, right? A plus B, right, is the same thing as B plus A. That's all the commutative property is telling you. That the order that you put the letters in, it doesn't matter when you add. So this is for addition. Okay? Is there another thing we can do to numbers where the order doesn't matter? Yeah. Multiplication. So I know I'm using letters here, but I'll give you an example. Like 3 plus 5 is the same thing as 5 plus 3. This is the commutative property. Let me rewrite this. Let me write this better. Multiplication, maybe it's different. Is it? 3 times 5? Is that different from 5 times 3? No, it's not. And this is very important. On New York Regents exams, they always ask about these algebraic properties. They always ask about the commutative property. So it's very important that you understand that it just means, oh, if I move the letters around for addition and multiplication, right, it's still going to be the same result, the same answer. Okay? 3 times 5 is the same thing as 5 times 3. 3 plus 5 is the same thing as 5 plus 3. Okay? But then you have another property that will show up. Associative property. So the way to remember commutative is commute. You move, if you can move it around, is it the same? Then you're saying you're using a commutative property. We'll do problems after this that are actual high school high school level problems you need to understand in order to graduate, where it will ask you, it will give you a whole bunch of things and tell you which of these properties applies. So that's why this is very important that you understand the language that's being used. The same way you have to understand the language that was being used for like the real numbers. It's the same thing for these algebraic properties. So again, commute. Can I move if it looks as though the letters are moved around, the numbers are moved around, oh, I was using a commutative property. Associative property, right? I think this just means you can put different groups of numbers, variables, numbers together and do an operation to that first. And say if you had done the group of the same things being added or multiplied, it would be the same thing. I know that sounds confusing. So the best way I can do is show you. So like say if we have 1 plus 2, say if we do that first, like that's in the group. We're doing 1 plus 2 plus 3. is that going to be a different answer than 1 plus 2 plus 3? Say if I do 2 plus 3 first and then add 1, is that different from doing 1 plus 2 first and then adding 3? Well, then what do we get here? We get 3 plus 3, and you get 1 plus 5, and you get what? 6 is equal to 6. That's all it means. Maybe my explanation word-wise wasn't the best, but associative property just means if I'm moving a group, right, of numbers or variables, I mean a letter, right? If I'm adding them, everything's going to be the same as this if I had grouped it differently. So again, it sort of stems from the commutative property. We didn't move the numbers around. We just did the operation of adding to this first, and then it was still the same thing as if we had added the last two numbers first. The easiest way to remember the associative property when you see it in an exam, there's always some kind of parentheses. That's the only way you can really see associative. There's parentheses. So one way I've tried to get kids to remember this is, you know how you have like there's a person, right? And so this, you can think of the ASS in associative as though it's someone's buttocks, right? So think of associative as, oh, there's parentheses involved, and it's showing you that the parentheses moved, right? The parentheses move. That's indication that this is the property that happened, okay? So that's one way you can remember it. So the ASS in associative is similar, right? Is parentheses, like buttocks, right? Like cheeks, right? Does it also apply for multiplication? But it does. We can check it. We can say, all right, 2 times 3 times 5. Is that the same thing as 2 times 3 times 5? So if you do the 2 times 3 first and times that by 5, is that the same thing as doing 3 times 5 first and then times that by 2? 6 times 5, 2 times 15, and then you get 30 is equal to 30. So just know that, again, these properties only apply for multiplication and addition, right? This one is addition. So again, associative is like, who do you associate with? The groups you made, right? Right? You and your associates is a group, right? If I do these groups and I add or multiply, it's going to be the same as if I did the different grouping of the same numbers. Okay? Do you want to?
One more, poverty?
I mean, should we explain this first?
Finish this.
No, let's do it. Let's do it. All right, so I'll do the last property.
Distributed. Don't erase it because I'm going to go over you. Yes.
So, right, commutative is pretty straightforward, right? Move numbers or letters around. When you're adding or multiplying, it's the same. You're going to get the same sum or the same product, the same end result, right? This one might be a little more complicated. Just know it's involved with parentheses. I can move the parentheses around, right? I can move the parentheses around when adding or multiplying, and the end result, right, of adding or multiplying will be the same. Okay? It's just you're changing the groups of numbers that you first did the addition or the first did the multiplication. But again, if you still add everything, it's still going to be the same. That's what's important. Okay. Right? And then we have the last one, distributive. This is the most used one in algebra. Okay? And then this follows, and this is why we approach the algebraic properties this way, in that commutative, right, associative builds on that. And so it makes sense I do distributive next because distributive builds on associative. When you see distributive, there will always be some parentheses there. So maybe the best thing I could do, let me not use variables or letters. Let's just use numbers. So let's say 2, right? And then outside here we have 3 plus 5, right? the distributive property says, all right, that this is the same thing as 2 times 3 plus 2 times 5. And if you look, you're like, well, how did I get this? Well, I took this 2 and I distributed it to both of the numbers inside the parentheses. Okay? In New York City, you might see some guys go down the block throwing out coupons from the grocery store, right? We say that they're distributing distributing the coupons. It's the same thing. Imagine the person going down and you're giving out whatever's out in front of the parentheses, you're giving it out to each thing inside. You're distributing it, right? That's literally why we call it distributive property. But is it true though? Well, 2 times 3 is 6. 2 times 5 is 10. And then we add it, we get 16. Say if we had used the associative property, which says what? I should do the stuff inside the parentheses first. I could have done that too. And then this would have been what? 2, and then in parentheses 8. Right? 2 times 8, 2 eighths. That's right. 2 times 8 is how much? 16. So isn't this the same thing as what we got here? All the distributive property means is you can, right, multiply whatever's outside in front of the distribute. You can distribute it to each thing. And it's important that you know distributive means you multiply, right? That's what you're doing. It's very important because I know some people might get confused. So like another example would be that a lot of mistakes are made. Right? A lot of students, I've realized, they see this, or like say if I have, let's 7 minus this, right? 7 minus whatever this is. I could, again, associative says, oh, go ahead and do what's in the group. Go ahead and do what's in the group. And I get 7 minus 7. Or with the distributive property, right? So you can look at this as like the associative, right? Distributive property would say what? This is the same thing as what? 7, and then you see this negative? I put the negative, I distribute the negative. 7 minus 3, right? Minus 4, which is the same thing as what? 0. This one trips up a lot of people. Just know though, you can, if it's in front of the parentheses, even a negative, you can distribute it. So this is a very common problem among students. They forget that you should distribute the negative inside. But that's it. Those are like the 3 basic algebraic properties that if you understand, if you see this problem in the regions, you won't get it wrong.
Good job. All right, Mr. Vos.